In notes number 2, we are going to talk about the points of concurrency. So where all of our special segments, if they are intersecting inside our triangle, what the name of that point is called. So with the median, this is called the centroid theorem, and the centroid of a triangle is located 2/3 of the distance from each vertex to the midpoint of the opposite side. So if you look at our triangle off to the side, CZ is our median, and our point, there's really no point for it or the label of it, but that's point P right there is the centroid. So now we can see that it is 2/3 the distance from the vertex to the opposite side. So you can see we have a longer piece, we have a shorter piece, and our longer piece is going to be twice as long as the shorter piece. If we have, say we have this segment is 5, that means that CP would have to be 10, because if we divide it in half, that would give us 3 equal pieces of our median, and we know that our centroid is found 2 of the 3 segments or pieces away from our vertex. The centroid is also called a balance point, and it is a balance point or center of gravity of the triangle. What this means is if you were to draw a triangle on a piece of paper, you drew your 3 medians, and you put your pencil where the centroid is, and you try to balance your triangle on that one point, that is the center of gravity. So you would be able to balance your triangle, but your pencil point would have to be right where the centroid is in your triangle. For the angle bisector, that's called the incenter, so where all 3 angle bisectors intersect in the middle of your triangle. And the angle bisector in a triangle intersects at a point that is equidistant from each of the sides of the triangle. If we look at our picture, if this is my angle bisector, it is going to be the same distance away from the sides of the triangle, and that would be 90 degrees to the edge of the triangle. In our figure, the angle bisectors intersect at point P, and point P is called the incenter. With our perpendicular bisectors, the name of the point of concurrency is called the circumcenter, and a point where the perpendicular bisectors intersect is equidistant from each vertex of our triangle. Remember, perpendicular bisector means that it is perpendicular to the side, and that means that it bisects your side as well. So XF is another perpendicular bisector, so it bisects that segment and it's 90 degrees. Same with XE is going to be perpendicular to that side, plus it is cutting it in half. So then, if you see these little dotted lines, if we connect that point in the middle, that's our circumcenter. If we connect that to the vertex, so each of these dotted lines, all 3 of those purple lines are the same length. So again, my purple dot in the middle is the circumcenter. That's the point where they all meet up in the center. Point X is the circumcenter, and X is equidistant from angle A, B, and C. Lastly, for our altitude, we have orthocenter. So the point where all the altitudes intersect is called the orthocenter. And in our picture, if we were going to list out what the altitudes would be, that is AD, FC, and BE, because we have that it goes through the vertex and it's 90 degrees on the opposite side of our triangle.